Hey, hello, and welcome to John Park's Workshop. I'm John Park. This is my workshop, and here we are. It is a rainy day here in Southern California today, and I've got the door down, so it's not as bright and sunny as I think we're all used to here in Southern California, right? But poor me. Hey, let's do some show stuff, shall we? Let's see. First of all, I wanted to check in with the chats. We've got. Let's see. Oh, is it on Twitch? It's not on Twitch yet. Well, that's weird. I don't know what to say about that. Looks like we're live on YouTube. Yeah. Let's see. That's funny. I had YouTube paused showing the playback, and yet it was sort of stuttering through, so I thought that there was playback problems there. But it looks like it's okay when I hit play. All right. Well, we're live on Facebook, I think, and YouTube. Hopefully Twitch catches up. What's up, Twitch? What's going on? We've got our people in the chat over here. This is the Discord chat. If you're over on one of those other services other than YouTube, we'll check the chat over there. But otherwise, please tune on in to the Discord chat, and that's where there's people chatting, hanging out, asking questions. It's a bit jittery, huh? I have no idea why. It looks like I've got smooth capture here. Yeah, I'm moving and it looks like I'm... how's the audio sync? I noticed there were big problems with last week. I have some plans for fixing that. The stream is slightly caffeinated. You know what? I've got some hot tea here today. Maybe that will or will not help. And thanks for the level check there, C. Grover. I noticed my audio was clipping the other day when I was playing back recording, so I won't go as hot. Here, maybe I can push the gain up in software, but I was pushing up my mixer software and it was clipping, which is no good. Hey, Twitch is live now. Good, let's get going, shall we? So first thing I wanted to do is mention that we have a help wanted board, and that is jobs.adafruit.com. And if you head on over there, you'll see we've got positions posted. Here's the jobs board. It's free to post. It's free to post a job position or an opening or contract gig or freelance work you're looking to have someone do, as well as your own resume if you're looking for work. Here's one I noticed that is new, at least to me. Let's see, it was published on March 12th. That's today. That's a new one. So Soundboard, Sage Enterprises, in Merrimack, New Hampshire, is looking to hire someone to do some contract work. The description is, hi, so I'm very new to this and didn't find anywhere for it, so here goes. I'd like to have one of these, but don't have the time to figure it out or make it. Would somebody make it for me on a commission? It is a soundboard. It is one of the Ruiz Brothers projects, 3D printed trellis original trellis with probably, gosh, I don't know what microcontroller was in that, and a audio effects soundboard, I believe. There are ways to do that with WAV files and a circuit Python board these days, and maybe the Neo Trellis. So if you're interested in picking up some contract work, check out the jobs board. That looks like it could be a fun little gig, a little side gig. So check it out. That's at jobs.adafruit.com. And let's see, the next thing I wanted to do was mention we have a coupon code for today. Wow, that's so funny. I've got a YouTube session open over here of what's playing, and it's lagged behind just by the nature of me broadcasting and then it showing up. But I've got it on pause, and yet every once in a while, like one frame of me shows up like it's a leaky faucet. That's weird. I guess that's apropos. Yeah, why did it do that? It's pause. It's not like play, but only occasionally. That's bizarre. All right, I'm going to move that out of the way because that's going to distract me. So I also wanted to mention our coupon code today, and that is Buckaroo. If you type in Buckaroo on checkout from the Adafruit store, you'll get 10% off all your stuff. That excludes gift certificates, software, and subscriptions. But you can buy some real cool physical goods and get yourself 10% off, which I think is always a nice thing. And as I like to do after I mention a coupon code, I'll give you a product of the week recommendation. And the recommendation I have this week is the Ringbit robot. It's this little cute robot kit. Comes in a little reusable, convenient sort of parts storage bin. And it's got, I haven't built one yet, as you can see. I've got mine fresh and new here, but it's got little bags of goodies. You put it together, and then you can control it with either a microbit or a clue board, which just fits right in the front there, as you can see. It mounts in there, and then you can run different software on there to do things. One example I'll show you is actually from the show and tell last night. This is cool. Hopefully my audio sync will stay in sync. Sometimes it goes weird when I hit videos. But here you can see this is Maker Melissa, who showed this on the show and tell last night, and that is the little Ringbit car, and she has the clue in there running a CircuitPython program that's using Bluetooth to control it over an iPad or an iPhone or an Android device. So we have the Adafruit Bluefruit Connect app, and this can drive a little car around. So you can see it's got turning, and it's got NeoPixels reacting, and then you could probably extend the software to print some stuff on screen. I don't know if Maker Melissa added readouts there, but you could do a lot of different info on there as well as reading some of the sensors that are on there. There's a ton of stuff you can do. You could do a real simple style version with the microbit, or you can get real fancy and use a clue board. So that's my pick of the week. It's cool. Ringbit robot. They call it the Ringbit buggy robot car. We have a lot of words associated with it, but that's my pick of the week. Let's see. Before I go into the next segment that I usually do, which is the MakeCode Minute, last week I did a new gear report. This week I'm calling it the gear report, but this is a retro gear report. And the retro gear I wanted to show you is over here. That's not a Q-tip, even though it looks like one. That's an alligator clip. But let me head over to my workbench there, and I'll show you this cool little piece of surplus gear I got. And I'd love people to help me identify what the heck this is. This is I got it at an aerospace surplus place that I like to go to. And it is a really, military spec or aviation spec panel, probably aluminum panel here, with a couple of indicators for a limit switch adjustment, close and open, and in arrows. And on the back here, we have two really beefy limit switches, very clicky. And I'm thinking something would be in here, and if it was off a little bit from where it's supposed to be, it would click one of these and alert you. You can see here, I hooked up a multimeter that has a nice continuity beep. And when this happens to be a closed circuit by default, so it'll beep as soon as I attach it. And then when I click, it'll turn off. And it has two separate ones, so that's the mystery part. I feel like there's something cool that this could be used for, but like I say, I feel like something lived in here, like maybe the handle to a door or something like that to indicate when something was not seated where it should be. It also has a little pivot point right in the center there that something probably would, a bearing or something would slip into. I don't know. But that's my gear report. That's my retro gear report. I think I paid $2.50 for that at a surplus place. So I now kind of wish I had more than one of them. But that's the mystery that I'd love help solving. In fact, let's hop over to our Discord chat. Any guesses? Cam in a housing to determine 2 to 4 positions. Okay, Dooster. Salt. Why did someone place a thing of salt? Oh, I'm not a financial professor. Take that advice with the appropriate grain or kilo of salt. Okay, I'm reading backwards through these, which isn't always helpful. All right. Yeah, that's my gear report. What the heck is that thing? Let me know. Or if you just have, if you don't know what it is, like me, but you have suggestions on fun ways to use it, I'll take those too. Because that is not Earl Grey, someone asked. This is English breakfast. And moving on then to our MakeCode Minute. All right, so for the MakeCode Minute today, what I wanted to show you is sort of an extension of what I started talking about last week, which is using JavaScript to enhance some of your blocks. And what I'm also showing here is the use of the button press in maybe not the most typical way. We usually use the button click event. It's the default. But you'll see here in MakeCode, there's actually, I'm going to zoom way up, in these input blocks on button A, normally it says click, and so it waits for a press and a release. But here I'm using the down and the up, which means that I can do different events based on pressing the button down and the button up. What you'll see here for button A is that I have these 2 JavaScript blocks. So when I press the A button down, I'm going to iterate through the 9 pixels, lighting them up, except I'm going to add 2 to the index every time we loop through. So that means I'm going to light every other pixel. Then when I release the button up, it's going to essentially hit the other set. Let's say we did the odd set and then the even set, or vice versa. So to see this in action, here's, let me show you, here's my Circuit Playground Express, and I'm going to press the A button, and you see it lit up with a little pause, each of those pixels. When I release, it lights up the other set. So press and release, and same with the B button. I have a different color set, so down, blue, up, lighter blue. So if you look in JavaScript here, some of this wasn't possible in blocks. In fact, you can't, again, using the generic or the basic block, you can't add 2 to the value every time you loop through, not in the header of that block. That block typically, if I pull one of those in, that's it. It says for index from 0 to a number. So this is a way that I can use JavaScript to change the behavior of that block, and also check out a different variation on the button, which allows me to have one event on down and a different event on up. Oh, I wasn't showing you that. Let me show you this this session here. I got away from it. So here you can see in the JavaScript, there's my first loop through. I'm doing +2. On my second loop through, I am doing this one here, and I initially set the index to 1 instead of 0, so that's going to go through the evens, or the odds, so first the evens, then the odds. And so that is a way that you can extend the functionality of your MakeCode blocks with JavaScript, and use the down and up button events to get different behaviors. And that is your MakeCode Minute. All right, let's pull that away for a second, and it got a little hot in here. I have a little space heater under there, but yeah, it's raining, but it's still not that cold. All right, let's see. In other news, I have a pick of the week that I wanted to show you for MakeCode Arcade. This is my game pick of the week, and let me pop back over to Chrome, and take a look at this pick of the week, which is Castle Crawler by our good friend Rehan Panchi 256, who has never corrected me on that pronunciation, so I hope I've gotten it right. And look at these instructions. Fight snakes and collect treasures. So I have actually, in an effort to make these run smoother, because the playback stutters if I actually play them in real time and then broadcast, I've shot a little video in advance here. And so you can see here, this is a dungeon crawler type of game where your character has a little sword, can kill these evil snakes. We'll presume they're evil and we're good. And you collect coins. And an interesting thing about this is I don't think I can skip through this, so I'll talk as we watch. But a thing that I found was really great is there's a vending machine for your hearts. Oh, here what we're seeing is a locked door. So there's a passage we can't get through. That'll matter in a minute because when we get to a certain spot, we'll open a mysterious locked door that'll suddenly be open, which is a typical adventure game kind of thing. You find a lever really far away from someplace you've already been, and then you know to go back there to get the door. So there are vending machines for picking up new hearts. I think we might be coming up on one soon. And there are, here we go. We're going to take out these snakes, and then you can see this really cute vending machine up here full of hearts. Love the artwork. And when you approach it and hit A, it says you can buy health. So that's what you can use your coins for. So I won't show you the rest of the playthrough, but I do want to show you a really neat Easter egg I noticed in the game. So let's bring up this code from the game. So there are the code blocks, and here's our on start, and we'll set up, you can see the character gets set up as well as a little text list, which is going to be used later for some random item you'll get from a treasure chest. But check out the tile map. I wanted to see what does this overhead view of the world look like? And check it out. Not only do we have the tile map, but if we look at, this is the graphics of the map as well as any of the sort of event tiles that when you cross something might happen or characters might be spawned from, snakes might be spawned from. When we turn the walls on, you can see these little red walls. There's a nice little Easter egg over here on the side, which is Izu loves NS. And I don't know who these people are, but I'm happy for them because, we need more love in the world. So I thought that was really cool to put a little Easter egg there. You will never get there in the map. This is sort of like an old 8-bit game Easter egg of yore. But it is there for you if you decide to poke through, which is one reason I recommend whenever you find a cool MakeCode arcade game, poke around in the assets and have a look and see what you find. That was really cute. So really great game. That is my pick of the week. It is Castle Crawler by Rehan Panchi 256. All right, so, hey, lots of me there. What I wanted to talk about now is our project of the week. So I am just kicking off a project that is using a brand new product of ours. It is the Bonsai Buckaroo. In fact, let me go back to Firefox here. Oh, actually, you know what? Before I do that, there was one other thing I forgot that I wanted to show you in Firefox, and that is our MakeCode Daily, or our Adafruit Daily newsletter, the MakeCode newsletter, at adafruitdaily.com. Just came out on Tuesday. If you're a subscriber, you got it in your email box, and you can head there to adafruitdaily.com to subscribe. And I wanted to give you a little glimpse at what was in this issue. So if I bring up the Firefox here, let me move this window, you can see here is our archive. So we have an archive page at makecode.adafruitdaily.com. So if you've ever missed an issue of it, you can head here. You can see all of the issues that have come out. And this is the most recent one. We have a featured item, which is a really cool Instructables build about a MakeCode powered flower pot that has a lot of similarities to the project this week. It reports on soil moisture using these NeoPixel, this NeoPixel ring. We also have an education spotlight, a couple of selected MakeCode Minute and MakeCode Arcade videos in there. And then there's news from around the web, a lot of different articles that we've found in the last month about MakeCode, including this really cool sewable circuits workshop that was at the Minnesota Felt Makers Guild, showing how to use electronics in your felt making. and on and on and on, including new hardware. So there's our ringbit car, as well as some other new up and coming hardware. Definitely interesting to check out. Here's a pretty cool one. This MakeKit microbit hoverboard. It's a hovercraft project, which looks really interesting. As well as this upcoming event, there's going to be a game jam, another game jam for MakeCode over at Itch.io. So if you're interested in checking out this and more, all the details are in the MakeCode newsletter, and you can just head to adafruitdaily.com to subscribe, or to makecode.adafruitdaily.com to check out the archive. All right, so the other thing that I was going to show you in here is, here's this product. Let's go to the old Adafruit, and I'll just type in Bonsai. So this is, if I go to a picture of the device itself, this is the Bonsai. It is a microbit and clue form factor board. Pretty inexpensive. It's $4.95 US. And it comes with screws. It screws into the bottom edge of the board. So here I've got a microbit, but I'm actually going to use the clue for this project. But there's that edge connector board, which also has these alligator clips, and we can screw through those into these standoffs. And it also has, as you can see on there, a wire block for a 3-volt motor. So we're going to use that in this project to drive a submersible pump, so we can pump water. And then we also have some of the alligator clip connections that were hidden by the board, broken back down at the bottom here, which is 3-volt. The pin 1, which we can use as an input or an output. We're going to use it as a resistance sensor, in this case, to measure resistance for soil moisture. And then there's also a ground pin, and we have a little speaker on there. So what I'll do is I'll head over to Workbench land, and we'll take a look at building a plant watering device. Now, before I show this one, actually, I'll grab this one off of the shelf here. This is a related robot I built a number of years ago for 3D printing project book. Let's see if I can get this down. I'm going to drop some parts and attempt to get it. All right, let's see. Oh, I've got a lot of wires coming off the back too. All right, this was unplanned, so bear with me, but I hope it's worth the wait. This is our friend Chauncey, who is a flower watering robot. Do I have it? I have it. Okay. So I'm going to get Chauncey's legs, but this is a 3D printed robot I built based on a design by illustrator and friend of mine, Barry McWilliams. And so this, oh, I'm hidden there. This little robot has a flower pot in the top and a little watering can. And see if it'll sit still there for a second. I can get Chauncey's legs as well. And by the way, if you're interested in this, the files are up there on the internet. It was a O'Reilly or Make book called 3D Printing Projects, I think it was. And so I have the files there. I probably have them on Thingiverse too, but I'd have to check. So there's this robot, and the idea here is that I have a couple of probes that go into the soil, and it measures the moisture level. And when the moisture level gets too low, I had a motor turning this little water kettle or watering pot to water it, dump its water out there. So let's see, I should be able to just move this off to the side. So that was done a number of years ago. I think I used a version 1 Adafruit motor shield on an Arduino, maybe Uno, or maybe older than that. I don't quite recall. So what we're going to do now is sort of modernize or update this project, and rather than using this motor to tip water in, I am going to use the clue. Let me switch to a large view for you. Get this out of the way here. So I've got a clue board here, and as you can see, it has a motor, a little submersible pump plugged into the output here, and then I've got a readout on there, and I turned that kind of dim, so I don't know how well you'll read it, but it says clue plant, soil moisture percentage. It's at 0 right now because I have nothing plugged in, and then the motor is pulsing on and off, which is what it does to fill. So what I'll do is I'll attach some alligator clips to 3 volt and pin 1, and then at the ends of these I have a couple of nails. Zoom out for you for a second so you can get the full picture. So these alligator clips each go to a nail, and those nails will go into the soil to measure the resistance. And at low resistance levels, it means that the soil is moist and we won't turn the motor. When it goes below a certain threshold, and we'll look in the code in a second and see what that is, it will turn on the motor. So right now I'm sort of shorting this circuit just with another small alligator clip, but if I take it out like this right now, you'll see it's flashing motor on, motor off. That's the text that's changing at the bottom there. And I'm hearing the little motor spin. So what I thought we would do is, I don't actually have any dry soil right now because of the rain out there, and the wet soil is kind of mud. So we'll do a simulated version of this now, and I'll do a better real version for the Learn guide that I do. So here's our pump, and it comes with a little bit of tubing here. And what I'll do is I'll submerge the pump in a container that I can put water in, and this pump draws water in through the side here and then forces it out, the tube. And then this will just be to collect the water. I'm not going to, my tea is going to have nothing to do with this other than I'm going to take a sip. So I'm going to take some water and fill it up so that we have a source to draw from. And now if we make sure that these are in camera view, if we place our probes in the soil actually of Chauncey here, you'll see it starts going. In fact, just while it's out here in the dry air, it'll do that too. So I'm going to take these nails just so that they're sitting somewhere. Oh, that's not long enough to reach up there. Okay, so you can hear it sucking wind now because we're out of water, so I can tip this, get this below level. So you can see it's doing a really nice job of forcing water up in there. And the idea would be, as soon as you get a good glug of water into there in a small pot like this, it's going to change that resistance level enough that it will stop watering it, so you're not going to drown the plant, is the idea. And then you can tune the settings in software to adjust. So why don't we take a look. I'm going to unplug power from the clue here, and we'll bring it over to my workstation, and we can take this tubing off of here. I don't want to pull this off. I actually accidentally broke off one of the little wire terminal things because I was unsure of how it worked. It's actually much simpler than I thought. You just push the wire in and it grabs. You don't need to use those clips until you're ready to remove the wire. So let me place the clue under the down shooter here for you to take a look at. And I'll adjust the exposure. There's not a lot of light over here on this, I apologize. And let's mess with the white balance too. There we go. That's a little better. And how about some focus? Decent, I think. All right, so what I'll do is I'll give this power, and we'll actually hear that motor spin. You can hear that turning, I think, and you'll see it's flashing the little LED, and it's giving us a indicator on the screen when it's watering. If I take my finger, which has a little water on it, and touch those two pads, I can probably get it moist enough to stop. Let me dip my finger in some water. And certainly you can just bridge that with the alligator clip, but this is, there we go, that's enough. So it might be at 50% or so. You can see there as it gets above, oh, now it's good and moist. So I'm going to actually hook my little alligator clip up to those two so it doesn't spin. I knew there was a reason I'd hung on to Chauncey all these years, so now I can update the project. All right, so let's open up my Moo editor. And this is the code. Is this the code? Let's load it off the board. That's okay. So the clue is plugged in. It's running CircuitPython, and it'll show up as a drive, as a USB drive. And I can zoom in on that so you can read the text a little better. So right now what we're doing is we're importing some libraries, including time, so we'll be able to pause. Touch.io, which is, I believe, being used for that pin 1 to do the resistance measure. Although I thought that was capacitive touch, so maybe this is capacitive. And then the Adafruit clue library is being imported, which is sort of a convenience library that takes care of a bunch of other things. So we have then this is why I have a dark display. I set this display brightness to 0.1 instead of 1. It's pretty bright at 1. And also this one is the, actually Lady Ada had set this clue._pixel 0 to 0. That's the NeoPixel LED on the back side of the board. And either that was for power savings, or I suspect she was working on this late at night and got annoyed by the bright LED. So that's a little trick you can use to turn off that back LED, which is usually used for status and a good thing to leave on. So then we set up the motor, which is on pin 2 here, digital in-out board pin 2, and it's set as an output direction. And then the speaker is set also as an output. Actually, have we been hearing beeps? I don't think I've been hearing beeps on this. Then the sense pin is being set as an analog input, so it should be measuring voltage, or resistance rather. Sense pin set at pin P1, which is the bottom one here on the little Bonsai board. And then there's a function that's set up here to read and average. Those analog ins are going to be sent to this when we run the main loop of the code, so that we can average it and get a sort of smoother value coming back instead of sort of spiky values. And then the clue display is being set up to run these text lines like we've done with other clue projects. And then here's what's happening when it runs. We're taking 100 readings and averaging them. So this is part of that smoothing I was talking about. So it sends the analog value, a value, is a variable that is the result of going and asking that function to read the analog pin 100 times and average them. Then a percentage of that value, which is 0 to 65, 535, is created. So a percentage is created from that. 0 becomes 0 to 100. And then we display that percentage up at the top, so here you can see it's reading 99%. I don't know why it doesn't want to get to 100, but it's at 99%. Then if that value is below 50, we're going to run the motor. The text will display that the motor is on, and it will also change the color of it to red instead of, or sorry, green instead of red. So this is 02550, that's the text color. And then when the motor value is above that, we'll turn it off and say motor off. So here you can see again, if I just set it to unplugged, it basically goes down to 0, and then it runs through that. You'll notice I don't think there's any code telling that LED to blink, so that may just be tied into the motor output, so you know when it's running. So that's a hardware level. That's nothing you're doing in software. And so now we could set our percentage as you figure out how much water is enough for your plant. Really, all you would need to do is go in and change this one value here where it says 50. This is the percentage here. And if you want, you could create a variable for that up at the top where it's easy to find and change. Or you can get fancy and have the buttons change that value for you, display what that value is on a separate line. I'm going to take this as sort of the launching off point. This is the sample code that I got from Lady Ada. And now I'll add maybe some graphics so that we can show happy and sad states of the plant as an adorable graphic. And who knows what else, but maybe play some sounds. I think the speaker was set up but not used, so we could do some little beeps on there. And that's my plan. So that's the project. I'll be working on this for the next few days and look for a Learn Guide to come out probably next week. And let's see, I think that's it. You know what I'd love to do is check in with the Discord to see if there's any questions or thoughts about that project. If I can find my Discord, there you are. And also, someone said, hey, I'm checking out the YouTube chat, and we had someone saying hello from Poland, hello. And they said, do they have a low volume? Let me see. Is my volume low? It shouldn't be too low. Hopefully not. There's a 1 to 2 second audio delay since the MakeCode community. Does this fix it? You tell me. From the moment I said, does this fix it? Because I believe this may be after hitting that video to play, I need to jump back and re-click my audio source. So darn it. I thought I had honed in on that. I had turned off some audios. Oh, nope, he says. I don't know what is causing that then. I'm going to try, I'll try some other things. No, it's still out of sync. It just doesn't want to catch up. That's interesting. So it seems like it's falling out of sync, but no matter what I click, it's staying that way. Oh, that's a bummer. Sorry about that. All right. So Toddbot in the chat adds this. He says, since it detects touches, we can use it as a face touching warning. That is very timely. Thank you, Todd, for that suggestion. Hex asks, hey, John, great project. Is there a way to determine the water level in the container via the clue Buckaroo? I wouldn't want the motor to be on when there's no water and the plant is dry. Oh, I see. So yeah, if you wanted to also be checking the level inside of the container, you probably could by connecting to like pin 2. So we're using pin 1 right now. Now the Bonsai Buckaroo, as you can see here, only has one pin that's broken out in a super convenient location, but you actually could still connect to pin 2 just like this. So you could connect here, you could connect to that screw, you could connect to that bit of that header in the back there. So you could use pin 0, 1, or 2, I believe, to check that water level. That's a great idea. So you would have a warning when you're low on water and a warning when you're low on soil moisture. So very cool. I'm going to make a note of that. I like that addition to the project. It's very cool. It's the advanced level. We'll do maybe some extend the project kinds of tips. Now, you could also get very fancy with this and connect something like our last week's project in, so that you're monitoring these moisture levels up on Adafruit I/O. By using the built-in Bluetooth on the clue board, you can send to the Raspberry Pi, which then is logging that data up there. You could tie in other things like Zapier or if this then that, so you could get text messages and phone calls and alarms and visits from your local sheriff. I don't know. It depends on how crazy you are about saving this plant's life. But I like that idea. Let's see, any other thoughts or questions? Yeah, Mike P over in YouTube says the volume is fine, but the audio is out of sync. Well, I am sorry about that. I don't know if we'll be able to correct that on the YouTube video. I will fix it on MakeCode Minute and any other small videos that I break out from there. All right, well, thank you so much, and I'll hang out in the chat for a little bit. Again, if anyone has ideas about the origins or use for my funny little gear report project this week, this little limit switch guy, I'd love to hear about it. And before I go, I will mention again that you can get 10% off in the store with the coupon code Buckaroo. Head there and fill your cart with cool things. You'll have lots of stuff to work on in case you are stuck home for a little while or at least not traveling as much. So maybe place an order for some neat stuff, get a little savings with that 10% off coupon by typing Buckaroo on the way out. All right, well, thank you. Yeah, thank you so much. I appreciate it. I appreciate you coming and spending your time here. And thank you, Dooster, for spending your time with us. And you're very welcome. I'm glad to be here. That's it for this week. So I will see you next week for Adafruit Industries. I'm John Park, and this has been John Park's Workshop. Bye, everyone.